Okay, welcome back. We're still on EE8, talking about probability of independent and dependent events. We remember that the probability of independent events is just take the probability of the first event times the probability of the second event. And the total number of outcomes on the bottom should stay the same if they're independent events. On dependent events, the second outcome might be different, might change because of something that happens in the first outcome. So let's look at another example. Let's look at another card example. Let's look at 4, 5, and 6. Okay, I'm going to write probability a little bit differently this time. Instead of putting it here and then putting it again here, I'm going to show you how it's typically written. Wants to know what's the probability of picking a 5 and then, that's what that, instead of putting it over here, I'm going to, and then picking a 4. And this one is dependent because it is without replacement. Without replacement. Okay? So here we go. What's the probability of picking a 5? Well, there are total possibilities of 3. There's 1, 2, 3 cards, and only one of those is a 5. So I have a 1 in 3 chance. But it's without replacement, so bye-bye 5. Now it wants to know what's the probability of picking a 4. Well, now there are no longer 3 cards, there's only 2 cards. So that's the number that goes on the bottom. And of those 2 cards, one of those is a 4. Probability of the first event, probability of a 5 is 1 out of 3. Probability of the second event, probability of pulling a 4 is 1 out of 2. Multiply those together. 1 times 1 across the top is 1. 3 times 2 across the bottom is 6. You have a 1 in 6 chance without replacement of pulling a 5 and then a 4. So that's basically how you do the dependent events. Now, I want you to keep something in mind, that when you're doing dependent events, there's a possibility that something's absolutely certain going to happen, and then there's a possibility that something is impossible to happen. Let's look at the first one, that there's a 100% possibility. So if you want to know what is the probability of rolling a die and it coming up a number less than 7, well, there are 6 possibilities. All 6 of those numbers, 1, 2, 3, 4, 5, 6, 7, are all less, I'm not 7, 1, 2, 3, 4, 5, 6, I mean, are all less than 7. 6 divided by 6 is 1, which is 100% possibility. So on that last example that we had, if it said, what's the probability of drawing a 5, okay, probability of drawing a 5, and then an even number, well, probability of drawing a 5 is still 1 out of 3. It goes off the table. Now, 2 possible outcomes, 2. Both of those are even, okay? So we end up with 1/3 times 1. That's the number 1. 1/3 times 1, because 2 divided by 2 is 1. It's a 100% possibility on that second one. We end up with 1/3. That actually happened on one of the examples earlier. I just didn't show it to you that way. But anyway, sometimes the probability is 100%. So, don't get a little distracted if something happens to be 100% possible or 100% going to happen. That's fine in math. That happens. The other one is when there's a 0% probability. So, what's the probability of rolling a die and getting a number greater than 7? Well, that would be 0 out of 6, which is 0%. Going back to our other problem, let's look at 4, 5, and 6. This one wants to know what's the probability of drawing a 5 and then drawing an odd number. Well, the probability of drawing a 5 is 1 out of 3. Now it's gone. There are 2 cards. There are 0 odd. So we know that this is 0 divided by 2 is 0. Anything times 0 is 0. So there's a 0% chance. So just watch out for those 2 possibilities and don't, get freaked out if you see them. All right, if you have any questions, let me know. Shoot me an email, and good luck to you. Thanks. Bye-bye.